The topic of this video is from Unit 3A on calculating odds. Odds are just another expression of the likelihood of an event occurring. The odds in favor of an event A are the number of outcomes in favor of A compared to the number of outcomes that are against A occurring. Now we write odds notation differently than we do probability. Instead of writing it as a fraction, we're going to write it as a comparison. So for example, the odds in favor of event A, let's say they're 3 to 2. That means there are 3 outcomes that are in favor of A and 2 outcomes that are against A. Now the odds against an event A are the number of outcomes against A compared to the number of outcomes that are in favor of A occurring. So if the odds in favor were 3 to 2, the odds against would just be the reverse of that, or 2 to 3. So we use the colon notation rather than the fractional notation as we did in probability. This distinguishes odds notation from probability notation. Let's go back to a previous example that we've looked at in another video, where a bag contains 150 pieces of chocolate candy. We have the red pieces, the brown pieces, the green pieces, and the yellow pieces. Now we're going to choose one piece of candy at random from the bag, and we're going to find the odds of choosing the following. First of all, we're going to find the odds in favor of choosing brown. Now it is a comparison between the odds in favor, the outcomes in favor of that event, versus the odds against. So how many outcomes are in favor of choosing brown? And there are 65 brown pieces compared to how many pieces are not brown. We're going to subtract the 65 from the 150. And that will give us a total of 85. Now just as with probability, we do need to reduce this. So we do have a common factor here between these two numbers, and it reduces to 13 to 17. Now the odds in favor of choosing yellow, well, how many yellow pieces are in the bag? There are 35. How many pieces of candy in the bag are not yellow? Well, we'll subtract that 35 from the 150 to give us 115. And this will reduce to 7 to 23. Now one thing you need to notice about the odds notation, in the notation that's not simplified, for the odds in favor of choosing yellow, the 35 plus the 115 totaled the 150. Now that is also true for the odds in favor of choosing brown. The 65 plus the 85 has to equal the total of 150. Now that is not true for the reduced form of the odds notation, but for the original form, the two numbers have to add together to give you the total. Now we've already calculated the odds in favor of choosing brown, but the next question asks for the odds against choosing brown. So actually all we have to do is to reverse those two numbers to get 85 to 65, or once again 17 to 13 in its reduced form. So the odds against choosing yellow would be 115 compared to 35, which reduces to 23 to 7. So oftentimes it's easier to find the odds in favor of an event and then reverse the two numbers to find the odds against. Okay, our next example refers back to the table of data for a group of people who owned Nissan crossovers. The results are summarized in the table. We're going to choose one person at random, and we're going to find the odds. Now we're finding the odds in favor of choosing a person who drives a Rogue. So how many outcomes are there for a person who drives a Rogue? Well, looking at the table, there are 110. How many outcomes are there for people who don't drive a Rogue? Subtracting the 110 from the 432 gives me a total of 322. Notice the 110 plus the 322 totals the 432 people total. So this will reduce 55 compared to 161. And then the odds against choosing a person who is under 25. Well, how many people are under 25? There are 168 of those. So in our comparison, the 168 will go on the right-hand side, and then we'll subtract that from the total of 432 to get 264. Now this does reduce to a comparison of 11 to 7. Now the odds against choosing a person who is under 25, that tells us that the people who are under 25, the 168 people, go on the right-hand side of the comparison. The left-hand side of the comparison are the people who are not under 25. Now suppose you roll a pair of fair dice. We're going to find the following odds. Right? We want the odds in favor of a sum of 3. Now once again, we are looking at this as a comparison. So how many add up to a sum of 3? Well, there are 2 ordered pairs that add up to 3, so that means there are 34 that do not. Now this will reduce to 1 to 17. Notice the 2 plus the 34 gives us the total of 36 outcomes. 2 are in favor of the sum of 3, 34 are against. Now the odds against the sum of 8. Well, how many outcomes sum to 8? There are 5 of those. Now since this is the odds against, the 5 goes on the right-hand side of the comparison and subtracts the 5 from 36 to get 31 that don't add up to a sum of 8. Now this comparison does not reduce, so the odds against the sum of 8 is 31 to 5. Now suppose you draw one card at random from a standard deck of 52. Find the following odds. Once again, we're going to write this as a comparison. How many successes are there? How many outcomes are kings? We know that there are 4 kings in the deck, so there are 48 that are not. So this comparison reduces 1 to 12. The odds against a black face card. Well, how many black face cards are there in the deck? There is, of course, the king, the queen, and the jack in clubs and spades. So we have a total of 6 outcomes that are black face cards. Now, why did I put that on the right-hand side of the comparison? Because this was asking for odds against, so that goes on the right-hand side. Now, how many outcomes are not black face cards? Of course, there are 46 of those, so this reduces to 23 compared to 3. Common factor of 2 in both of those.